A very good morning, my dear students. I am Dr. Vivek Singh, Department of Electronics and Communication, Nagarjuna College of Engineering and Technology. So, in today's session, we will discuss the concept of line coding in a digital communication. So, first of all, why line coding is important, that we first discuss. After that, we'll start the classification of line coding with the help of the example. So, what is line coding? So line coding is a technique in which we will represent the binary data sequence in the form of the waveform. So line coding, we have a number of classifications. So I am going to represent the each and every classification, and under that classification we will represent the we will explain with the help of examples. So very first line coding technique is a unipolar NRZ format. The second classification is a unipolar RZ format. What is the nomenclature for that NRZ and RZ that I will tell during the when we will draw that waveform with the help of the example. Second technique is a polar NRZ. Next is polar RZ. Next is bipolar NRZ, which is also known as alternate mark inversion, AMI. The full form is alternate mark inversion. Next line coding technique is SPM, that is split face Manchester, and the last one is M array coding technique. So what is unipolar NRZ? So unipolar, according to the nomenclature, when you will see two nomenclatures are there. First is a unipolar and second is a NRZ. So suppose, for an example, suppose we have a one binary data sequence, that is 1, 0, 1, 1 and 0. So let us represent this binary data sequence in the form of the different line coding technique. So this is the 1-bit interval which is represented by TB, and suppose I want to draw the line coding technique for this one, unipolar NRZ. So unipolar means you have only one polarity, either it will be a positive or it will be negative. Generally we are taking the positive polarity. Suppose for a symbol 1 we are representing it by +A, and for 0 we will represent it by 0. So the waveform will be like this. For 1 we are drawing positive signal +A, for 0 we are drawing the 0 signal. Again when plus will come, we will represent it by +A, again 1 will come, continue, 0, it will be 0. So here you can check for the whole bit of interval, your pulse is either high or it is low. For symbol 1 it is represented by +A, for 0 it is represented by 0. That's why this type of line coding technique is known as a unipolar, because here we have a one polarity and the waveform is maintain its voltage level for the whole bit interval. That's why it is called a non-return to 0. Next line coding technique is unipolar RZ technique. So let's draw one more line, one more axis, so time axis. Again for a symbol 1. So here for unipolar RZ, again the voltage level will be A. But what is the meaning of this return to 0? Return to 0 means what? When symbol 1 will be there, for half of the bit interval, your pulse will be high. For remaining half of the bit interval, it will return to 0. That's why the nomenclature is return to 0. This is the difference between RZ and NRZ. In RZ, for the whole bit interval, the pulse will be high. For RZ, your half of the bit interval will be high. Remaining half of the bit interval, your pulse will return to 0. For a 0 symbol, it will follow the 0 as it is. Again, for 1, what will happen? For 1, again for half of the bit interval, it will be high, and for remaining half of the bit interval, it will return to 0. So into continuity, again when 1 will come, half of the bit interval, it will be high, and then it will return to 0. For 0, it will be 0. So this time interval is what? TB by 2, half of the bit interval. That's why this line coding technique is known as a unipolar RZ technique. Now next is a polar NRZ format. What is the meaning of polar NRZ format? Here you can check, we have a polar, we don't have the terminology unipolar. It means we have both the polarity. We have positive polarity as well as negative polarity. So for a given bit sequence of 1, we will represent it by positive polarity plus A. And for the symbol 0, we will represent it by the negative polarity. Suppose it is minus A. So here you can check that we have both the polarities. For symbol 1, we are following the positive for the whole bit interval. And for 0, we are following the negative polarity for the whole bit interval. So this is what? This is the concept of polar NRZ. Again, NRZ is there. It means the waveform will maintain its voltage level for the whole bit interval. Now we'll go towards the next, which is what? Polar RZ. So polar RZ, again we'll draw one waveform with the help of same example. We'll try to understand the concept of polar RZ. So again, because it is a polar RZ, so what will happen? For half of the bit interval, it will be plus A. For remaining half of the bit interval, it will return to 0. Again, 0 is there. So for half of the bit interval, it will be what? It will be minus A. For remaining half of the bit interval, it will return to 0. Again, 1 is there. For half of the bit interval, it will be high. For remaining, it will return to 0. So we'll follow the same. So it's very much simple. No need to learn any technique. Whatever be the nomenclature is there, you have to focus on the nomenclature. In that nomenclature, everything is mentioned. If it is a polar, it means both the polarity will be there. If it is a unipolar, only one polarity will be there. If it is an RZ, your pulse will be high for whole bit interval. If it is a RZ, your pulse will be high only half of the bit interval. Remaining half of the bit interval, it will return to 0. Again, we have a high. So for half of the bit interval, it will be high. Then it will return to 0. Like this. Okay. Now next is your AMI. What is AMI? Again, AMI is the alternate mark inversion. The nomenclature is important. You please try to understand the nomenclature. So alternate mark inversion means what? For successive ones, the polarity will change. 0, it will be 0. Suppose for this one, you will represent it by plus A. 0, it will be 0 as it is. Nothing will change. But when next one will come, then it will not be plus A. It will be minus A. That's why the name nomenclature is alternate mark inversion. For a successive ones, you are changing the polarity of the voltage level. You are changing the voltage level from plus A to minus A to plus A. So for next one, it will become minus A. Again, for next one, what will happen? For next one, it will become positive. Very good. Then it will become 0. So here you can check that for the first one, it was plus A. For the next one, it was minus A. Then again, for next one, it was plus A. So for the whole bit interval. This is called what? Alternate mark inversion or bipolar NRZ. It's very much simple. No need to learn anything. You just follow the nomenclature. Everything is written in the nomenclature only. Now we will go towards the last line coding technique, which is not the last one, the second last, the SPM, which is a split phase Manchester. Again, the very important and interesting line coding technique. Again, the nomenclature is SPM, which is a split phase Manchester line coding technique. In that split phase Manchester line coding technique, what will happen? For half of the bit interval, let me draw the line again. It will be here only, because when we will go down, so it will be difficult to see. So suppose this is your plus A by 2 and this is your minus A by 2. So for one bit interval, what will happen? In split phase Manchester, for symbol 1, for half of the bit interval, it will be plus 1. For remaining half of the bit interval, it will go to the minus A by 2. So here the negative minus A by 2, the negative polarity, the positive polarity is followed by the negative polarity for symbol 1. What about the 0? In a 0, for half of the bit interval, it will be minus A by 2. For remaining half of the bit interval, it will be plus A by 2. Again 1 will come. For half of the bit interval, it will be plus A by 2. For remaining half of the bit interval, it will be minus A by 2. Again, for half of the bit interval, it is plus A by 2. For remaining half of the bit interval, it will be minus A by 2. And for 0, minus a by 2 first, then plus a by 2. So here you can check. Here you can check that in a single bit duration, the phase of the pulse is changing from positive to negative in between. That's why the nomenclature is what? Is split phase Manchester technique. Okay. So thank you till split phase Manchester. That M array coding technique we'll discuss in the next lecture.